week 9, and we'll spend this week talking about the calculation involved in calculating the size of thermal expansion tank. They come in different sizes, and there are two types, either open or closed. The open one usually used for commercial buildings or power plants, but for residential usually we use a diaphragm tank. It's called a diaphragm tank, it's because it has a diaphragm in it. And if you notice, your hand upside down, guys. And if you notice in the bottom, there is a Schrader valve to pressurize the system. And this is the diaphragm. So you have to pressurize the system to make sure it's in the same level of or water pressures. So we'll go through the calculation. Does anybody have this calculation sheet?
Yes.
Who doesn't have it?
Yeah,
Have extras.
What?
Anybody have it?
I'll take one. Yeah, I don't have one. Actually, I don't have one. I have the other one.
It's good to know.
Do a three-hole lunch.
Huh?
Do a three-hole lunch.
We got one here. So if you don't have it, please ensure you have all the information. We'll go through it step by step and see how does it work out. If you look in the sheet, there's a whole section for thermal expansion tank, starts in here and continues in the back. So all the information you need are in this sheet. Keep it with you and we'll go through it step by step. So thermal expansion tank comes not after the pump, before the pump, because if you put the pump before the expansion tank, it's going to pressurize the system here, and you will lose a lot of pressure.
Okay, so you say it goes after the pump?
Before the pump, because otherwise you will lose a lot of pump head because this will push the water inside the pump. What is it called? Thermal expansion. Because the water, when it gets hot and warmer, it will expand. And when it expands, it will push around the system, and it might cause you to have a leak. So this just to compensate for the water expansion due to temperature. And if you under pressurize the system, you'll have a vacuum and you'll have bubbles. It's not going to perform as it's supposed to. So we want to calculate what is the right size of the tank to have in the system to be able to pressurize it correctly. So if you look at the equations, they look a little bit involved, but all this information you will find from the chart. Don't let it intimidate you. So there is something called P charge. What do you mean by P charge? It's the pressure of the system as is without being heated. So P charge is the pressure of the water as it exists in the system, and it's compromised of the height, because again, height of the system will give it the water a lot of weight, and that will push on the system. So it's called the P fill or the P charge. 5 is a constant, it's not going to change. Height of the system, which is the highest point of the system, and it's also defined in here if you look at the little definitions. So H system is the height from the boiler room floor to the highest system components, or the height from the highest system component to the tank. So that's the height of the system. From the boiler to the top point of the system. Height of the tank, usually the tank is around 6 feet or 5 feet. So you will subtract the height for the system. Actually, you subtract the height of the tank and the height of the system. So if we imagine that we have 3-story boiler. This is my boiler here. This is my thermal expansion tank. System's going up. This is my height of the system. Let's say 30 feet. The tank here is 6 feet. I'll subtract the height of the tank from the height of the system to get the height from the tank to the top point of the system. Make sense? Raise your hand if you don't, does it make sense to you?
Wait, what? Sorry, I was looking
Huh?
No. I think
at,
that's-
I zoned out. What?
I also zoned out, if that's
Okay.
the correct term.
Get in the zone again. So the height of the tank. Basically, I want to know what is the height of the system, of the water that I'm calculating. So the height of the system is the highest point in the water system. So
Okay.
from the bottom of the boiler, the top, bottom floor to the top level. So that's the height of the system. The height of the tank is where the tank is located. 6 feet, 5 feet, 5.5, and that will give you this portion of the equation. Okay? D cold is the density of the water when it's cold. Where do we find that? In this table. So if the water is at 60 degrees Fahrenheit, what is the density? Exactly. If the water cold temperature is at 50, 62.41. Look at the sheet, it should be there. So the temperature, a lot of people mistake that and they put the temperature of the water in here. So if you put 60, you get the wrong number. You put the density, D is density. And if you look again at the definition, it will say it right here. Density cold, D cold is the density of the water felt at fill temperature in pound per feet cube. 144 is a conversion, which is 12 by 12, which is conversion from feet to inches in size. So this will always be the same. So we constant, huh?
That's constant.
Yeah, this is constant, this is constant. What you gotta look up is the height of the system, height of the tank, and the density of the water when it's cold. Any questions about that? Make sense?
And that'll give us,
Huh?
that'll give us the calculation for peak load or peak charge.
Yes. Once you get that, we move to step 2. So either we're going to have an air cushion expansion tank, which does not have a diaphragm in it. If you come through it, we're not gonna use that, but in case you have to, this is the equation for it, which is air cushion expansion tank, or diaphragm expansion tank. This is the diaphragm expansion tank. So we'll look at this equation here. We have to calculate the volume of the system. What is the volume of the system, guys? If you think of the hydronic system, what would be the volume of the water inside the system? Just think of how much water is in the system. What would that be? The volume of the water in the boiler, correct? The volume of the water in the pipes, correct? So that, if you look here, it's also in the sheet. And it says V system calculation, V pipes, V boiler, and V radiators. So all the pipes in the house will have water in them. All the pipes in the radiators have water in them. So that will be the volume of the system. D cold and D hot, you'll look it up in the back. D cold at 60 is going to be 62.367. What is the hot water usually?
180.
Huh?
Are you talking about the temperature out of the faucet?
No, out of the boiler.
180.
180. That's the most common one. So let's look at 180. And what is the density? 60.57. Any question? It's all from the table. Okay, -1. If you reverse these, you'll get something less than 1, which means at the end you'll get a funky number here. So this is supposed to be bigger than 1. You subtract 1, you get a fraction. Something less than 1. We'll see that with a good example. Okay? PRV is the pressure relief valve. If you look at the back, if you look in here, it says PRV, relief valve pressure setting, which is usually what? Throw a number.
Oh, so PRV is the pressure relief valve?
Yeah.
Oh, okay, so at like 15?
More.
30?
30. So this pressure is usually 9% is 30 psi. So again, that's a really easy number to find. 9.7 is a constant, leave it as is. PRV, do we know that? Same as the top. What is P charge? You already calculated it, right?
Yeah, so the pressure relief valve is usually 30 all the time.
Yeah.
Unless you got some
Yeah,
funky.
yeah, 9 out of 10, it's 30. I will give you the number, but if it's not giving, just put 30.
Alright,
We good?
yeah.
Question.
Yeah.
So the first equation and the third equation, you're doing no matter what, to figure out what tank you need.
Yeah.
So you always have to do two equations.
Yes.
So when you use the second one, when you have the diaphragms?
Yeah, which is not very common in residential, but in case you have to, you use the second equation. I'm not gonna ask you this, but if you have to, you can use this. What is 14.7?
Atmospheric pressure?
Yes, and because it's an open tank, that's why I use atmospheric pressure. This is a closed system, we do not worry about atmospheric pressure. Yeah. Okay, so we have a lot of variables, and to give you an example, this is my expansion tank here. So the height will be the highest point of the system, which is here, minus the height of the tank. And this is a simple system with all components in it. So again, heat tank, the minimum tank size, you can go higher a little bit, but this should supposed to be the minimum. If you have less than that, the system will leak as it gets hot. And again, does your car have an expansion tank? Yes, it does. That's where you fill your radiator fluid, right? And you can see there's lines on it that says what is the level when it's hot and what is the level when it's cold. When the car is cold, you see it's very low. When the car warms up, it goes a little bit higher. And should not exceed. If you fill to the brim when the car is cold and you turn the car on, it heats up, it will overflow and start to leak. Okay? And if you notice the tank has a very small, have a cap that will not seize pressure, and we sometimes have a vent, so if this thing's overfilled, it will spill over. This system, we calculated the total volume of the water in the system, which is three things: the water in the boiler, the water in the pipe, and the water in the fins. Density of the water filled in temperature, that's those two things we get from the table. The tables here give you the density of the water. And again, a lot of people, the last 4 years, they always, instead of the density, they put the temperature. So don't do the mistake. P fill is the pressure at the air cushion that's in the tank, or the P charge, they have the same calculation, which is the pressure of the system as is without anything, based on the water weight. P relief valve pressure setting, usually 30 psi, unless something else has been provided. Height of the system, height from the boiler, room floor to the highest system point. So from here to here, that is my height of the system. The height from the boiler room, each tank is the height from the boiler room floor to the tank. So 6 feet, 5 feet, you measure it by a tape measure, and that'll give you the height of the tank. Clear?
Yeah.
Can have this with you in the quiz. It's just filling the blank and doing the calculation step by step slowly. You should be doing well. So again, when you do the order of operation, of course the equation is kind of involved. Just be patient and do it step by step. This is PIMDOS. Yeah.
So when you mount the expansion tank, does it have to be vertical or can it be horizontal?
No, it has to be vertical. Unless it's designed differently. But most of these design ones have to be vertical.
Like if you have like a space issue, could you put two smaller expansion tanks that would add up to the correct size?
I think it has to be to the design, because if you think about, if you put it sideways, it will bend and break the pipe. It's not designed to be put sideways, unless you have it to be supported. If you support the tank, probably you can put it sideways. It's mainly for the weight, and it will expand sideways. Doesn't matter, but it's a good question. This is designed to be hanging from the top or vertical. If you put it sideways, you might have to provide support for it. Good question. So when we do the math for that, it's parentheses, exponents, multiply, divide, and finally addition and subtract. This is the order of operation. And again, take your time and do it step by step. Don't try to rush it. So this is a calculator for the blackboard that you can plug in the numbers and it will calculate it for you. It's my calculator, so if you have a mistake, it's my problem. So you put in your information here and it will calculate both times for you. Just double check your work. For the project, you can use that or you can use it by hand. But I want you to know how is the equation is running behind the scene. So here, V cold, you have to look it up. V hot, PRV is 30, height of the system, height of the tank, volume of the system. So we'll have some fun calculating the volume of the system, and I'll show you how. If you look at the sheet again, if you look at the second table here, it says the volume of the water inside the pipe. So how do we do that? We're going to calculate the total length of the pipe and see what kind of pipe size is it, and you multiply it. So if you look at any pipe, what is the volume of this water? It's the area here, 2 pi r, times the height for the length, the square length. It's not always work. So the area, you get the area, and you get the length. And this here will give you the area based on that inch. And you can see the copper and steel have different areas. And that is because for copper, they use the outer diameter as the nominal. What does the nominal mean? It is the common one, what is known for. So a 1/2 inch copper isn't the same size as 1/2 inch steel. Because for 1/2 inch steel, they use the outside diameter, not the inside. So you'll use this number and multiply that by the length of the pipe. That will give you the volume of the water inside the pipe. Okay, we got that done. What about the size of the volume of the water in the radiator? It's also just the pipe. So you're gonna go and see what size the pipe is in the radiator and add that. If you have a different baseboard radiator or a mattress radiator or a convector, you might want to see how much water is in that system, in that boiler. Okay, what about the boiler water content in the gallons? Usually it is labeled in the boiler. If not, you can calculate the boiler BTU. You should know the boiler BTU, it's supposed to be on it. If not, if you don't know how much BTU this boiler is giving off, probably you can find out from the nozzle based on the amount of oil it's putting on. So you get the boiler BTUs, you divide it by 1,000, then you multiply by 0.186. And that will give you the volume of the water inside the boiler. So B system. Pipes. Okay. And why do I ask about the volume of the water inside the pipe? Because for these kind of radiators, it's really hard to know what is the length of the pipe inside. So usually you have to look it up. It should be labeled on it. This one is old, so it doesn't have a label on it. But if I have to go and just guesstimate how much water is in there, what would I do? This is 1/2 inch pipe, and I can calculate how many turns does it take, and use it as a pipe. That'll give you how much water is in there. I'll say it's around a gallon or so. So it does make a difference And probably you can have some chipboards and some other radiators. So we'll do an example as well. Water density, it's here. So this is how you find a density based on temperature. And again, which is denser, cold water or hot water? Cold water is heavier than hot water. So it makes sense that cold water has 62 pounds per feet cube. As we heat the water, it loses density, becomes thinner. So at 180 we have 60.57. Okay? So system volume calculation. Again, volume in the pipe, volume in the boiler, volume in the radiator. Okay, and the volume of the cylinder is the area of the cylinder, that's the cylinder, and the length. So this is the area of the cylinder, this is the length. Unless you have a mysterious shape. This is the volume of the pipe, and again, it's right in front of you here. So if you forget, I think all the pieces of the information is in this sheet. This is the pipe size from 1/2 inch to 2 inches, the area inside, and the length. And let me explain also why does a 1/2 inch steel pipe is different than a 1/2 inch copper pipe. Talking about nominal. So when we talk about nominal, half an inch. One of them will calculate the 1/2 inch as the outside, and one of them is the inside. So for the, if you look at the copper, they go by the outside. This is from here, here is 1/2 inch. And the steel, they go by the inside. That's why it's a little bit bigger, and that will make a difference when you calculate the pipe size. Questions?
Wouldn't it be the other way around?
Huh?
Wouldn't it be the other way around?
So the copper is smaller.
Copper is inside and.
Oh, steel is small. Sorry, yeah, you're right. Thank you. And if you remember the second lab we did last semester, when we did the threading and cutting for the steel, we go by the outside because the threads are done by the die. You do the threading from the outside, so we want the outside to be consistent. Okay. So let's do an example. Volume of the boiler. When you're purchasing a new boiler, the amount of water contained inside the boiler are labeled with the boiler in gallons, which tell you how much is in that boiler. Where do you think that water is? It's containing the heat exchanger. So inside the boiler, if we this is the air going through the tube, and this is the pipes, the water. So this is the amount of water in the boiler. If you don't have that number, you can calculate it using this equation. So for example, if we have 60,000 in those numbers. I should be getting the boiler size. That's around 11 gallons. Got it? So that will conclude how do we calculate the volume in the tank, and we will do a few examples and practice next class. Make sure that we got the idea, and it's not that complicated. It's following the steps and doing it one step at a time. So now besides the pump, yeah.
Take a picture of the one.
Once we size the pump, we size the pipes and the expansion tank, we're ready to put some control. And our control will be a thermostat, wherever you want the temperature to be measured. And where do we usually put the thermostat? It's usually in the hallway or the furthest from the radiator. Don't put the thermostat near the radiator or a heat source, otherwise it will overheat the temperature. Aquastat is necessary for hot water system, and zone valves for each zone for circular pumps, and you will need a primary control to turn on and off the boiler. So let's do this example of calculation. It looks intimidating from the beginning, but once you try to lay down the information, it should be easier. So here we have a relief valve. T code 60. Neglect the heating unit volume, which is the radiators. Assuming in this case probably we assume that the pipe size is the same as the radiator size, 3 quarters. So it's a 1-story house with a ceiling height of 10 feet. So that will be
That's gonna be system height.
system height, age system. Out of the tank is 6 feet.
So we're gonna look for the heat charge first, right?
Yeah. And the copper pipe is 1 inch. Pipe length. Boiler BTU. I would like to know what is the
200 feet from the pipe.
huh?
200 feet from the pipe.
Sorry. Okay, let's start an expansion tank for this. So the first thing I want to do is I'll give the P chart. That's 5 plus age tank. Age system age system age tank times D code. What is D code?
60 degrees, so 62.37.
Where'd you get the 10 minus 6 from?
A system is 10, times 10 is 6.
Oh.
Okay. I will run the numbers. I got it. 0.433. And now I'll do the multiplication first. So the problem will happen when you do the math all together and you don't do the bin casting. Do the parentheses first, so you can get the right number.
Where does 62.37 come from?
That's the density of the water when it's cold.
Oh. Yeah.
We're good? So we get the key charge. Sweet. Now let's get the volume of the system. Look at the sheet. Sheet is here, it says V pipe. And I've been told that neglect the heating unit volume, so this goes to 0. And what is the V5? The volume of the pipes. The volume of the pipes are copper. Did I say that? Yeah, copper 1 inch. So I'll go to copper 1 inch, and that's 0.46. Times 200. Volume of the boiler is 5,000. 50,000 over 1,000 times 0.186.
So what are we calculating now? The volume of the tank? Or no,
Volume of the water in the system.
Okay.
This will give me here 92 plus 50 times 9.3. I have 101.3 gallons. So now going to the big equation, I have all the unknowns that I need.
So the copper piping you got for gallons, you got 0.46 when it's 0.046.
Did I miss where is that?
I would assume it's gonna make a big
Oh
difference,
yeah, of
right?
course. Thank you.
So that should be a 9.2.
Give me 18.5.
And there's no radiators in this one?
No radiators. I mean, less than radiators with 5 liters. So now I'll put the big equation, which is 3 tank B system times What is the volume of the system?
Volume in the system, that's P fill, right? 6.73?
No, the volume of the system is over there,
Oh,
18.5.
18.5, all right.
What is D called?
62.37.
D hot?
60.57.
Minus 1. What is PRV? Gas? PRV.
30 psi.
Relief valve?
Oh, 30?
No?
It's right there.
Yeah, 30.
You said no.
You see a 3 or 30?
I see 30.
PRV is 30.
I just said 30.
Oh, didn't hear me. So 30. This remains the same, 9.7. This PRV again is 30. What is P charge?
6.73.
6.73 minus 5. That's too much. But we'll do it step by step. Now, the magic happens where we have to go step by step. What is 62 over 0.37 over 60.57? That is 1.029 minus 1 times 39.7. I'll go one more step. 18.5. It's going to be 0.209 plus 39. Multiply it all together. I got 1.165. So what is the volume of the expansion tank? 1.65, so 1.5 gallon will do, which is much smaller than this one. So this is the minimum. So you can go from 1.5 gallons for that system. So just about steps. Wash it. Oh. Think it's doable?
What?
That's crazy.
Huh?
Are you doing more this on Wednesday?
We'll do a lot of these. We'll do a lot of these on Wednesday. Okay? He's laughing at me. Step by step, you have all the equations, you have a calculator, it shouldn't be. All right, thank you.